Hi, everyone. My name is Corey Maynard, and I'm an engineer in the Substation Department 30, specifically site development. However, I've recently been working on an underground transmission project, a duct bank project for Eversource Energy in the city of New Bedford, Massachusetts. The focus of today's recording is not to discuss the design of the actual duct bank, but to discuss the capabilities and the method that we're using to design and create the drawings and iterate upon those drawings and the capabilities of Civil 3D specifically with labeling and updating as new information comes in from the various levels of survey. Before we dive into the software, I want to give you a brief overview of what a duct bank project requires in terms of drafting and plan production. What we're essentially doing is running a series of pipe networks underground through a city, down roads and various rights of way, trying to avoid existing infrastructure such as water mains and sanitary, storm sewer, manholes, things of that nature. Products of this nature often entail crossing various jurisdictions, and it requires coordination with various government bodies, and it results in a lot of constant iteration on plans and producing you know additional drawings for permitting processes. On this project alone, we're crossing a mass DOT interchange project, which required a whole lot of coordination because they'll be working at the same time that we're coming through, and they're putting in new storm sewers as well as sanitary. We're also crossing several City of New Bedford proposed projects, and there's coordination required there, as well as horizontal directional drilling underneath a river. Will be about 60 feet deep under the river, which requires, as I'm sure you can imagine, tons of coordination with the DEP, EPA, and various concerned governing bodies. We utilize plan and profile sheets to show our layout, and both horizontally and vertically, of our duct bank. Um, we also use it to show the placement of our proposed manholes and the routing of the conduits around and through the various manholes, and the various typical sections that will be used during the course of the project. With that understanding in mind, let's jump into the software. Here's an example of a set of plans that was drawn in base AutoCAD without utilizing geospatial referencing or 3D objects that we can use in Civil 3D. As you can see, this would be a typical plan sheet. There's obviously an XREF survey, so that's just coming through. I trust everyone understands how XREFs work, so I'm going to turn off the XREFs so that you can better see what is happening live in this drawing. This is essentially what you have, are just lines. So these are just lines that someone drew, probably copied, and I'm sure they have some, nifty ways of getting it laid out. But this is just a piece of dumb text that someone would have to come in and edit individually the stations. So if, and these are calling out existing infrastructure. So this case is the water main with a quality level D called out at station 19 plus 66. The individual stations here, these are just text that someone would have to come in and edit. Someone would have to place this arrow. I think you understand the point that it's, for the most part, the alignment is drawn. It's not 3D in nature. It's two-dimensional line work. These are just pieces of text, and these are just lines. The alignment itself is created by just a polyline. If something were to change, nothing updates. If I move this line, nothing moves with it. If I add additional curvature, the stations do not adjust. Similarly, in the profiles, so that drawing is utilized to create the plan view with the survey XREF, and then similarly, this is where the profile views are created, and it's just lines that someone drew. The profile itself, just lines. None of these are geospatially referenced. In other words, the coordinates are not relevant. They're just based off of 0, 0. However, this does seem to be the current industry standard. And so you can imagine that on a set of plans of this nature, with constant updates, updating all of the station callouts and radius callouts and all of the various pipe networks and offset pipes, and their labels and elevations, accurately projecting the existing grade above the duct bank. All of these things would be very tedious and time consuming. And anytime that there was a change horizontally, that would affect everything downstream, both horizontally and vertically. The placement of all the manholes, the stationing of all of your profiles, and the elevation shown would all have to be individually updated. And on smaller projects, that's not as big of a deal. But on projects of this nature that are 4 miles long, you have hundreds of sheets. And one change affects everything downstream of that sheet. So you can imagine the hours spent just in drafting alone, utilizing the base AutoCAD and the current industry standard methods. What sets us apart from the industry standard is the ability to utilize different software, Civil 3D to be specific, which is basically AutoCAD, but with just different tools, to create these sets of plans and to do a lot of the drafting and automate a lot of this stuff for us. So let's jump into the software. We'll start with this plan and profile view, which is essentially a very, very similar view to the one I showed you before. However, you'll notice something different. If I try to select stuff in paper space here, nothing gets selected up here, only the blocks down here. And the reason for that is that in order to draw inside of here, these are actual viewports, which if you can, think about it this way, it's a window into model space, right? So I have to click inside of here. Same thing in plan view, I have to click inside. And when I click inside, you can see the crosshairs rotate. And that's because north is actually up, because everything inside of this viewport and in model space is actually geo-referenced correctly on planet Earth where it would be. To show you a better example of this, let's jump over to our corridor drawing. And let's see. Let's turn on our background map. So when we jump in, we don't just start drawing anywhere on the screen. If we were to, the actual 0, 0 coordinate would be way down over here somewhere. What we do is we set the coordinate system based on the survey that we received. And in this case, NAD 83 Massachusetts State Plane is our horizontal datum. And once we set that, we can utilize geospatial referencing to correctly locate our project on Earth, and draw it, in 3 dimensions at depth. Most people, when you think of 3D modeling, you probably think of, like an architectural clay model or, something like that. Maybe even 3D printing models or something like that. And it is true, we are creating a 3-dimensional model, but that's not the real benefits. The real benefits come from being able to sample the 3D model and label it based on, it's not only that, but identify conflicts, and there's all sorts of various benefits to having an actual 3D model correctly located on planet Earth where it is. So here, for instance, we see a conflict. There's a existing sanitary pipe, sticking right through the duct bank. So we could dive over top of it, similar to what we did here, or go, underneath it, similar to what we did here, to avoid that. However, having a 3D model like this to look at really doesn't benefit anyone. The real benefit is like I said, the ability to sample it and use it to label things and to extract information and iterate quickly and efficiently without having to redraw a whole bunch of things. Essentially, we can control the entire profile from this one drawing where I designed the entire 4-mile duct bank. I've set all the elevations of the manholes that I, based off of a template that I use to connect to the various typical section points and inflections and things that you would see in these profiles. And I can update the entire profile as one thing at a time. Both the top and bottom will move in unison. And this will affect everything in all drawings, in all sheets throughout the entire project. Even though these sheets are not being created from this base design drawing. This is just where the profiles are being shortcutted from. So similar to X references, Civil 3D allows the use of data references. And so we can create 3D objects such as surfaces and alignments and profiles, and then we can data shortcut them to other drawings and use them in other drawings without editing them. That does several things. One main thing that it does is save drawing file sizes. You can imagine that on a project of this size, it's hard to even turn the survey on because of how much it bogs down your computer. But utilizing Civil 3D, we can draw an entire project and control all of the other drawings from this one drawing. To give you a couple of quick examples of some of this functionality that won't take too long. Let's say something as simple as drawing an alignment. The old method of drawing the alignment would be to literally draw a polyline where you want to go, fillet that polyline, draw another polyline at your station main one, copy it, maybe paste it 50 feet down, then maybe 100 feet down. Then grab a piece of M text, move it into position, rotate it, copy it down, change that number. This would be the process of drawing an alignment. Doing it using Civil 3D, however, you can automate a lot of that. So I won't go through the process, but it really doesn't take very long. It's similar to drawing a polyline. In fact, you can create an alignment from a polyline, and it will automatically station it for you. If you decide to add, or change your curvature or move it around, things will automatically update. As you can see here, let's add a 50-foot radius curve. Boom, everything updates. Everything downstream of that will update. Not only will it update here, but the profile views that are being created from that alignment, they will update automatically, and all of the items inside of that as well. Another example of that might be like the manholes. We have to show the manholes in profile views. And not only that, I need to see them in order to grade the duct bank to where it's supposed to be to attach and to make it through the manholes. So I've already graded these out in the main profile drawing like I showed before. So I don't want to have to do that again to be able to utilize it in my corridor drawing. So I have a restricted profile view here, but basically I'm supposed to have 2 manholes right in here, and they're missing. So I could go and start measuring and drawing a square and figure out my manhole's somewhere right there and make it look all nice and stuff. Or I could just go down, and since I've already created these actual 3D manholes and I've set their elevations, I can just project them into the profile views. So I can grab the object, bring it up here, project objects to profile view, boom, and it comes in automatically scaled and automatically labeled. We can have it label it however we want. We can give it an individual name based on what the name of the block is. All sorts of different nifty things to automate its position and things. Something else that's pretty neat is just to show how these things update. Jump over here. So if you notice, the current station is 9 plus 55, roughly 9 plus 55, and the manhole's here. If I were to move this manhole, it will automatically update. right? And the station will automatically change. So that applies, that's pretty powerful if you think about it, because it applies to not only, these objects, but all of the existing pipe networks, um, the profiles, the existing surface above all of this. All of that's very, very powerful. On top of that, we're able to create, utilizing corridors, the excavation corridor, which essentially shows the three-dimensional pit that will have to be excavated in order to install the duct bank. And we can use that surface to measure a volume, um, and tell us exactly how much excavation there is. We can produce tables very quickly utilizing Civil 3D tools as well. And all of the labeling and um, necessary changes to keep the set of plans up to date, utilizing Civil 3D tools, can be done in just a fraction of the amount of time, since the changes apply everywhere in the entire set of plans. One additional point that I want to make, with utilizing Civil 3D and some newer type software modeling things, is some of the just final product benefits, look and feel type things, ease of navigation, everything just down to our anywhere in the plans that we're referencing in a sheet in the plans. There's a hyperlink to that sheet. For instance, I can click on this sheet; it's going to take me there. If we're referencing another plan sheet, like here, we're referencing, if you want to see what's going on with this bypass, go here. So you can click on that; it'll take you there. Same thing with the typical sections. If you want to go see the details for those, you can easily get there, and go backwards. So those things help, I think, reviewers, and shows a little bit of our professionalism and our ability to stand apart from the competition that's out there. I think the sets of plans that we're able to generate look pretty good. And again, anything changes, the speed at which we can iterate upon and get this set of plans back out, I think will really set us apart from the rest of the industry. So I appreciate you taking the time with me to go over this. And if you have any questions, please feel free to reach out. I do think these tools could be utilized in other aspects of our industry, everything from substation to power gen, maybe even overhead transmission lines. If you'd like, any more information on Civil 3D or some of its capabilities, please feel free to reach out. Have a great day. Thank you.